5.8. 5.8 and 5.9 are very similar in nature. We're going to notice with 5.9 that we're going to have equations with fractions, but the variables will be in the denominator. But in this section, we're going to specifically be looking at examples where, well, I shouldn't say specifically, where most of the variables are in the numerator and we have fractional coefficients for equations. Okay, so let's jump right into this actually. First, the easiest way to solve an equation with fractions is to multiply everything by the LCD. This was method number 2. You recall from yesterday or 2 days ago? From 5.7 we looked at a first method and a second method. The second method was to identify the LCD and then multiply the numerator and denominator by the LCD. Here we have an equation. And we're going to go right into the first one here, and we're going to multiply the LCD. So let's start this one off. Right away, it's very tempting just to multiply by 9. Because it clears out the 9 and the x squared. It makes the right side 4.5. But the middle one, you have 9 over 6. That's going to be 3 over 2, which is 1.5. Which just makes it a little bit messy. It gives me more decimals, right? So the rule of thumb that we just went over is to find the LCD first. Find the LCD first. What's the LCD of 9, 6, and 2, George? 18, not 54. 9 times 6 is 54, but that's not the LCD. Okay, if you didn't know it was 18, remember what do? Prime factorization. Okay, so this is a prime factorization of 3 times 3 times 2. No, sorry, just 3 times 3. 6 is really 3 times 2. And this is really 2. So if I wanted to think about what's in common amongst them all, well, they all need to have at least 2 3s and at least 1 2. 3, 3, and 2. What does that multiply to give you? 18. So this is your LCD right here. The LCD is 18. So we look at the equation. And we multiply everything by the LCD. What does the first term become? George? 2x squared, because 18 over 9 is 2. Luke, after that?
Then you have,
Come on, focus, man. Right after, we just did 2x squared. What's the next term?
Wait, I'm lost.
Go ahead.
Would it be 3x?
3x. And then the last term, Bridge?
Equals 9.
Good. Gotta focus, come on, man. I wasn't trying to cold play. You gotta listen.
Yeah, I see that.
Okay, 18 over 6 is 3.
Yeah.
Now, multiplying by the LCD eliminates all of the denominators. Okay, it eliminates all of the denominators. Another method to use here, which I was taught in school, which is fine, but I find this to be easier, is to make an LCD for everything and then just cross it off. So for example, like we could solve this, it's a quadratic, we'll solve it in a moment. But for example, instead, if I had thought of this problem, I'll write it down here at the bottom. Okay, if I go back to the original looked like this. Okay, this was the original. I could have also said, well, the LCD is 18. So what's missing here to make this 18? What do I have to multiply by to make this 18 in the denominator?
2.
2 over 2. Okay, so the first one, I'm going to show you the other method. You don't have to use it, but I'm going to show you it. The second thing you would multiply by 3 over 3. And the third part, to make that an 18, you would multiply by 9 over 9. What do you notice? 18, 18, 18. Look at the numerators. 2x squared. See that? Minus 3x equals 9. 2x squared minus 3x equals 9. So in reality, if I were to get an LCD for everything, I could then just look at the numerators and it would give me this anyhow. So that's why I just take the LCD and multiply in all 3 spots. It's just faster, that's the only reason. Okay? This would literally become, ready? 2x squared minus 3x equals 9. This part would be over 18, and this would be over 18. If 2 things are over 18, does it have any significance? No. It's like having 7x equals 7. 7's cancel, x equals 1. Or 7x equals 14y. It's not solvable. But the 7 and the 14 reduce. We know that we can cancel things. So theoretically here, the 18 that's in the bottom can cancel on both sides. So when I say cross off the denominators, I literally mean they cancel, leaving you with the numerator that I've just circled in blue. It's the same thing you would get in both cases. So this alternative method in the bottom right, I'm showing you, but to be honest, it definitely takes longer. So I would recommend using this method. Either is fine though, okay? Either really works. And now all we have to do is solve. I feel like this factors, it does. 2x and x, and it could be 3, 3 or 1, 9. 3, 3 or 1, 9. Any ideas? Take a guess, take a stab at it. Kate, what do you got? Plus 3 minus 3, I will agree. Let's check to make sure real quick. This gives me 2x squared. Outer gives me negative 6x. Inner gives me positive 3x. Well, negative 6 and positive 3, that gives me that. And then multiplying these two things gives me negative 9. So we're good. So our answer here is going to be negative 3 halves. And our answer here is going to be 3. Now, these problems are really no more difficult than what you've done already this year. Okay, these are not any more difficult by any means. All you need to remember is to clear out your denominators to make it easier. This is going to lead us into problems that are more difficult, so that this should be pretty easy right now. Again, clear out the denominators to start these problems. Look at the second one. Look at the second one. Instead of an equality or an equation, we have an inequality here. It does not change the process, though. Still, clear out the denominators. What's the LCD in this case? What's the LCD between 4, 12, and 1? Those are my three denominators. My three denominators are 4, 12, and 1. What's the LCD, Max? It's 12. Again, this 3 is really over 1. Everybody recognize this, please. Okay, I know it doesn't really matter, but I want you to see that. Now, if I multiply everything by 12, which is the LCD, I put a 12 in front of everything. Now, the 12 times 5x over 12 is obvious. 12's cancel, right? Please cancel those right away. And you're just left with 5x. And then 12 times 3 is 36. So the right-hand side is actually much easier. How about on the left-hand side? What does that become, George?
It becomes 12x minus 1, which is 68.
It becomes what?
12x minus 1, which is 68.
12x minus 1?
168 over 4. And then you just...
Ooh, why would you go through all that work? What did I do already, George? Help me out. Follow what I did instead.
You cancel.
So what should I reduce to then?
3.
Over? So do that first. I think that'll make it easier. You distributed first, right?
Yeah.
If you distribute, George, it makes the numerator really large, and then you have to reduce them both by 4. It doesn't make much more sense, right? Because you can take a shorter route. If you guys were trying to cut across Central Park, you'd probably just find like a diagonal and go across, or a path to cut across. You wouldn't necessarily go all the way around, right? That's the same thing here. So that works, George, but the most direct route is to reduce first. This then becomes 3x. I have to distribute the 3 to both of these now. Okay, 14 times 3 is going to give me 42 in this case. So I have 3x minus 42. That's a 3. Let me make that look nicer. Okay, again, please reduce whenever possible first. This 12 is really over 1. The 12 and the 4 reduced to 3 over 1. And now we solve this like any other inequality. I'll move the 3x over to the right-hand side. By subtraction, I'll add the 36 over. And I'll get my solution. Can somebody point out anything here that could have been done differently that would have made it tougher or longer? I took a certain route here, besides what I already mentioned, with the canceling out here. From here down, I did this a specific way to make it an easier problem. Can somebody explain what I mean by that? Why did I make it easier by taking this direct route? What do you think?
You combine like terms, or you move the x's to the right and the constants to the left.
So that was one thing I did very good. I combined like terms 2 at a time, right? I moved the constants to the left, and I moved the variable terms to the right at the same step. Definitely saves me time. What else did I do? Or why did I do it that way? Kate?
Is it like the way you move the x's? Because like one way with negative is like you have to switch the sign.
Yeah, let's go over that real quick. Take a look, please. Take a look up. Had I moved the 5x over here, this becomes a negative 2x, right? And remember, when you have a negative as a coefficient and then you divide by a negative, what do you have to do to the sign? You have to flip it. So to avoid having that mistake of having to flip it, I made sure to move the 3x over here to yield a positive coefficient so that when I divide by a positive, I don't have to flip the sign. Doesn't matter, obviously, they're both correct because you would get the same answer either way. If you did it the other way, the answer would literally just look like this, which is the exact same thing, right? X is less than or equal to negative 3. Either way, that's how you would read this. The solution is x is less than or equal to negative 3. Annette, question, or you just kind of, your hand was up there?
Oh no, it was no.
Gotcha. Questions at all? Clear out the denominator, solve as per usual. The third one's a little bit trickier. 4 and 5 are much trickier. But the third one's a little bit trickier. Okay? It's a little bit trickier. LCD. LCD. 6. So multiply everything by 6. Okay? Please don't multiply the numerators out. Cancel first. 6 over 2 is just 3, so this becomes a 3s squared. Next, 6 over 3 is just a 2, so this becomes 8s. And 6 over 2 is simply, again, 3. So that's a 3 on the right-hand side. Subtract the 3. Now, at this point, how do we solve? How do we solve? Quadratic inequality. What's the approach? Approach?
Well, you could do the quadratic equation.
Good, so get roots, right? But they're not called roots now. What do we call them instead of roots? What was the phrase? Got it?
Was it the point?
Oh,
If they're very important points, you call them. You hear me? And that other hand, help out. Critical points. So yeah, that's fine. Find the points. Find the critical points at this point. So you could factor here, or you could use the quadratic. It turns out this is factorable. So my critical points are negative 1/3 and 3. Now, I'm not done. Those would be the answers if this was an equation, but it's not. It's an inequality. So I have to remember to plot these on a number line now. Wait till you get the calculus. You guys are going to be like, that Mr. Howell, that technique he showed us with this, now it makes sense why he did it. Because right now you're like, this whole number line thing, it's a little bit slow. This will help you so much in calc. And you don't even, most students going into calc haven't ever even learned this idea. Okay, so it really will help you. There's a 3, and there's a negative 1/3. Now, we test the regions. The testing of the regions is what you're going to use in calc also. So testing these regions, pick points that make sense. In the middle region, easiest point to test.
1.
Or?
Negative 0.
1 or? 0. Negative 1 is out here, right? So we'll get to that, yeah. But in the middle region, either 1 or 0, I would use 0 personally. And remember how I told you to test it? Where do you test it? In the?
Function.
This is one time you don't go back to the original. In the factored form, it's much faster. So let's watch what I'm going to do, or you guys go ahead and do it also. I'm testing 0. Plug a 0 in here. Plug a 0 in here. A 0 here makes this positive. A 0 here makes this negative. Positive times negative is? Only like 2 of you, but right? Negative? Doesn't matter what the number is. I don't care. All I care is if it's negative or positive. How about the other 2 regions? What do you think? Probably go positive. They are. Think about a parabola. Remember the shape of a parabola? I can tell you already that this graph, if you were to graph it, would look like the following. Here's what the graph would look like. I'm telling you right now for sure. That's what this graph would look like if I graphed it. What is the inequality? Remember, what is it really telling me? This is telling me that this function is below the x-axis in this region. And look at it. Isn't it below the x-axis here? And what part of this function is it? Above the x-axis. So what are these signs going to probably be? Positives. Okay, remember, the number line is really telling you whether or not the function is above or below the x-axis. That's all it's telling you. So if I plug in a number like a 4, test 4, 4 is out here. Plug a 4 in here, this is positive. Plug a 4 in here, this is positive. Positive, positive is positive. That's why this graph is above the x-axis over here. Annette?
Now, would you have to do all of that? Could you know already the answer of the negative or positive thing if you looked at the sign for A and
Technically speaking, yes. If you know your math well enough. If you know that A is positive, it means it opens this way, which means you're going to have a negative loop in the middle and positives on the outside. If it were this way, it'd be a positive loop in the middle and negatives on the outside. The only problem you're going to run into is if you have a double root. This was like s equals 2, s equals 2. Because then you have a tangent, remember that? And it touches the axis and returns. It doesn't cross the axis. So for those, you just want to be careful. But yes, you could, technically speaking, do that. So if I test -1, it makes this negative, it makes this negative, which in turn makes this positive. Our question said, when is this statement, when is this expression greater than 0? That's what it's asking you right now. When is this expression greater than 0? Greater than 0 means positive, so I use these regions. How would I write my answer for this problem then? It's a solution set, remember. How would I write my answer for this problem? Just Kate, the only one that can write this solution set? Come on, just list all the positive regions. That's all you got to do. Look here and list the positive regions. Give me one part, Ned. X is less than negative 1/3 or what? Or x is greater than 3. Very good. What's the other approach? That's the solution set notation? Interval notation?
parentheses, negative,
Negative
-3, parentheses.
1/3.
Oh, yeah.
Got you, go ahead.
And then another parentheses, 3, comma, infinity.
Good. Why come? Oh, why come? Why not, or how come there are no brackets? It's not showing up. Airplane is delayed, guys. How come there's no brackets here? No brackets, no brackets, no brackets.
Because it's not greater than or equal to.
Very good. If it were greater than or equal to, you use the bracket to indicate that it is included in the solution set. If I were to graph this solution set on a number line, my final answer would literally be this region up here, shaded in, and this region over here, shaded in. Okay, that's what my number line. Airplane's not working. You gotta be kidding me. Still not back. Questions on this one? So we've had a simple one with an equation, a simple one with an inequality, and then we've had an inequality that's a little bit more complicated. Okay, let's jump now into a couple word problems. 2 word problems for the day. 2 word problems. Take a minute, actually. Let me see. I want to see how much time we have before I go. Perfect. We have about 15 minutes, so we want to get through both these problems. So please start. Read it with the person next to you. Try to come up with some sort of an approach. Try to start with an approach, okay? Figure out how you can begin this kind of a problem. It's chilly here. Cold? You ready?
Okay, so I'm on studies. Okay. So we don't, first of all, we don't know how many members there
X
are.
equals total amount of members.
We want to make the x equals statements. That's a good idea.
And so we know that.
So x plus.
You guys, don't just go to the answer. I want to see an equation. I want you to write out what's happening here. So you could literally write like a statement in English with an equation, right? You can use words and then replace those words with variables.
X minus.
I know you can practice.
Only 6 people.
Because the reason I'm pushing you on that is because it's going to get tougher in calc and it's going to get tougher in your advanced courses because you have everything ready. You probably go to a lot of it, but even on the AP exam, they're going to want to see all your work. They have to show your work. So, oh yeah, a lot of it, almost the whole test. Yeah.
So we know that.
How is that actually?
No, it's
That's what you're going to have to calc.
Minus 6.
I know. Well, the AP exam is half multiple choice. The other half is for response, you have to write everything out.
No, 6 people.
I'm trying to think about this one.
Good. Do exactly that. Try to think about it logically.
Yeah.
What would happen? If suddenly less people were coming to the game, what would happen?
Yeah.
Cost you more money, right?
What is you just said the total number of money.
The total number is 36.
No. We need Z equals money
Hold on. What did
per person. So 360. 360
He knows who this is.
equals.
He just thinks right
Divided by 6.
Peeps.
Guys, this is my approach when I'm thinking about it. It's not necessarily the answer at all, but this is how you should be thinking about it, okay? That's a little hint if you're having trouble. It might help you.
Thank you.
Actually, really. Let's use that as the beginning.
Well, no, wouldn't it be?
Let's use this to start.
It's $2 per member added, not just 2 in general.
Yeah, so right now it's going to cost me, say, $10. But if everybody else was still going, it would only cost me $8.
Well, it costs the same amount as for the total thing, but like each person is paying more.
That's what this is, the cost for actual people. So right now it cost me $10, but had you 6 not canceled on me, well, you screwed me over, it would only cost me $8. See what I'm saying?
Yeah.
So this is the cost it was originally, which was a less cost, and to that you get the actual cost now. Per person. This is the per person cost.
I don't know, this is confusing.
Right.
X equals Y.
I mean, just think about it.
It has nothing to do with 360.
Guys, there's 10 of you in the class, right? We go to a baseball game next week. The game altogether costs us $500. There's 10 of you. Each of you have to pay $50. Luke says, you know what? I don't really like baseball that much. And Ashley says, I'm going to get the high score in the math competition today, so I can't make it. So we have 2 people not there. So you have 500 now divided by 8 people. Because we can't get rid of those tickets. So now that we can sell those tickets, we already bought them, right? So now the cost of everybody goes up. That's what's happening here. Originally, this many people are going, and now fewer people are going. So this is going to be greater than $50. So we know how much greater it is. In this case, it's $2 greater. So this would have been $52. Not in this problem.
You just got Y.
Yeah.
That's an issue.
It's all about your let statement. Your let statement.
Y equals.
What did you let m or y or x or whatever variable equal in this problem? And you can answer in more than one way. There are 2 correct approaches here. What was your let statement? Anybody have a let statement for me that they want to use? Good.
Let x equal the original cost per person.
Original cost per person. No, not going to work. What are we trying to find? Read the question, Annette. The very last statement,
Well,
Annette.
how many members went?
So let x equal.
Let x equal original amount of members.
Sure, that works. Does that work for everybody? Can we do that? You could also let x equal the actual number of members. Either way, it doesn't matter. They differ by how much? 6. Okay, it's either going to be x minus 6 or x plus 6. So if x is the original number of members going, where does that go? Original. The original number of members going, where would that go? George?
I would go on the one with cost or whatever.
Yeah. Now, is it going to go in the bottom or in the top?
It's gonna go on the top.
What goes up top? What should go up top? How do I find the cost per ticket? That's what this is, right? This is the cost. It would have been per person if it had been the original amount of members. What do I take?
The 360.
Yeah, divide that by the amount of people that would have gone. Okay, that'll give you that part. Now, it's delayed, guys. There's a 360. Put a 360 here, please. And then plus 2. There it goes. Now, you like that? Did I try that with you guys yesterday? No, I was in a class. I was like, yeah, it's delayed. It's about to appear now.
And then you said it actually happened.
Now, it just wouldn't work. The left-hand side, though, how many people are actually going? Are x people going actually in the end? X minus 6. So that's your denominator now. And what's the cost overall, though, still? It's still 360. So this is the equation. There it is. This is the equation we need. There it is. All right. It's kind of funny, actually. Another thing you could have done instead, and if you look at my notes, let me point this out real quick before you even continue this problem, guys. In my notes, I called this x, so I called this x plus 6. Because originally weren't there 6 more people going? So if I call this x, I could also just call this x plus 6. There's 6 more people going originally than there actually are. That's the same thing as saying the original amount is this, and this is 6 less. We could just say this is the original amount x, and this is 6 more. It's no different at all. Okay, so either approach is good for a problem like this. Now, this problem, the only thing I want to point out before we go through solving this, because we're going to have to multiply by the LCD again, the same way we did. What can x not be, based on my domain restrictions? What can x not be? What values?
It can't be negative.
It can't be negative, agreed, because it's the number of members going, agreed.
It has to be more than 6.
Has to be more than 6. Why?
Because 6 members left. So.
Yeah, if 6 members left, you have to have at least 6 to start, right? Now, looking at the math here, if I have a 6, 6 minus 6 equals, you can't divide by 0, so you know that's out, right? So it can't be 6, and it can't be 0 because of my domain, but because of the logic of the question, right? We know already x cannot equal 6, x cannot equal 0, but we also know that x must also be greater than 6, not greater than or equal to, but greater than 6. Because any number that's less than 6, like 4 or 5, wouldn't make sense. If you only had 4 members to start, how could 6 drop off, right? So the logic behind the question is what also gives you a domain restriction of the fact that x has to be greater than 6. Now, what's the LCD for a problem when we're really unsure? What do we do? Simplest way to find an LCD when you're really not sure, George?
You do factors, so
But can x minus 6 factor?
no.
Can x factor? So they're already factored, right? So George, if I want an LCD and I don't have anything else besides the factors, what can I do with the factors automatically? To find the LCD, I could always do what to the factors?
You can multiply.
Yeah, to multiply them. So my LCD is simply x minus 6. That's the LCD in this problem. When in doubt, go ahead and multiply. Stop, or you're going to have to start notes on paper. Stop. X times x plus 6 gets multiplied by every single term. Now, this is when it's very useful not to distribute. Remember George earlier? We talked about distributing. Cancel first, because watch what happens. Ready? Do it right up here. Put your factors that are or your LCD right up top, please. In each part, we have some cancellation going on. In the first term, x minus 6 cancels. In the second term, the x cancels. Do we all see what I just did there? It makes more sense to reduce first and then distribute. So the numerator on the left becomes 360x. In the middle, it's 360 times the quantity x minus 6. And on the far right, it's 2x times x minus 6. Take a look and make sure this all makes sense, please. We identified the LCD. We multiplied every term by the LCD, which resulted in this line right here after cancellation. Then it's just a matter of solutions, right? So I've gotten this problem 360x equals 360x minus, what is that going to give me? 2160 or something? Is that right? Plus 2x squared minus 12x. What's on both sides? George?
360x.
Yeah, that drops off. It's on both sides. Cancels. Leaving with 0 equals 2x squared minus 12x minus 2160. Again, subtract 360x on both sides. It drops off. 2x squared minus 12x minus 2160. Please, this minus sign does not go away. When the 360 drops off, the negative is attached to the 2160. Okay, factoring this is going to be messy, but it does actually factor. What do we get as an answer here? What's x going to equal in this case?
Well, I was going to say, wouldn't it be like really hard to factor, like,
Yeah, would you factor that?
no,
What would you do?
the quadratic?
Yeah, so go right to the answers. What do you get as answers? Forget the factors, because you wouldn't want to factor this. What do you get, Max? What do you get?
Negative 30.
Negative 30 is one answer, and the other answer is? It's two answers, right? It's quadratic. Just plug in the quadratic formula. Come on.
I did. On my calculator. I only got negative 30.
There's a problem with your program then, for sure. Take a look at it. Other answer, other answer, other answer, other answer, other answer. Come on. $36. Now, how many people? Sorry, what does X stand for? Go back to your let statement. What does X stand for?
The amount of people would have been if the people hadn't left. So
Yeah, the original amount of people. So originally 36 people were signed up. How many actually went though?
30.
30. Okay, the question said how many actually ended up going. So the actual answer, so you reject this because it's negative, and then you do 36 originally, minus 6 that canceled, giving you 30 people attended. Okay, 36 was the original amount of people that signed up, 6 dropped off, 30 of them actually ended up going. Guys, if you can't get from here to here, you got a problem, really. You gotta be able to go from here to here. Okay, so practice, you need to use your quadratic formula to do that. Okay, I'm not going to show that work. We're at the point of the year where we've done that many times. It's not worth our time. Tonight, here's what you're doing. You're listening to this example and going through it. It's a lengthy example. I recommend that you take my advice and I use like a table method to solve a problem like this. I use a table of values. It's very, very useful to approach it this way. Okay, please watch this question. You're going to be lost in the next lesson tomorrow. Okay, so tomorrow, this is not on the quiz. Tomorrow's quiz, 5-6 and 5-7. Finish up 5-8 and get to the homework, please, tonight. Have a good one.
Thank you.
Officer.